The test I'm going to explain now is called aggregate crushing value. Aggregate crushing value test or experiment. This is the first experiment we will be doing in Transportation Engineering Laboratory. CEB 4331 is the code for the subject. Alright. Well, aggregate on the right side, I have a picture there. Hang on a second. Yeah. So for the road work, to build the pavement, we use bituminous concrete. The usual which we are familiar with is cement concrete. It has coarse aggregate, fine aggregate, sand, and the binding material is a cement, Portland cement or other types of cements. In road construction, we use bituminous concrete. We use coarse aggregate. Instead of fine aggregate, we use a different graded stone chips. And for binding material, we use bitumen. Long time ago, we used tar from coal. Nowadays, we use bitumen, which is a byproduct of petroleum distillation process, the refining process. All right. What we will be doing is finding the crushing value of this aggregate. What is that? We want to see how much we can crush it. We are just finding out, is it crushable? Is this stone piece or these stone pieces crushable? So we put it in a crushing testing machine, and then compression testing machine, and we see how much powder or how much dust results by crushing it. After you crush, there will be some solid part still remaining, and you will have some powder, kind of like the remaining, or the one that results from crushing, something like a dust. So we want to see how much is that dust. See, it's kind of strange experiment, right? We don't find the strength of the stone there. What we find, we crush it and see how much it is crushable, how much powder gets as a result, and we see the ratio of the complete powder kind of dust resulting from crushing with the original weight. So it will be a ratio, it will be a percentage. So if that percentage is very high, that will mean that the stone is crushable. It became powder. That's not good. So if in the results, if we get higher value, that means the stone is not up to the standards. But if suppose the value is lower, like 3%, 4%, which means out of the weight you took for the test, only 3-4% became like in the powder form. So that is okay, that's good. Alright, so that's what we are going to do. We are going to take a sample of this gravel, stone, aggregate, and prepare them for the test as per Indian Roads Congress principles. And then we do the test, measure the value, and then we record it. Alright, that's all about this test. Okay, so how to do that? In person, when we meet, we will demonstrate this in the lab also. You will have a chance there to learn in the physical laboratory, right? Laboratory. For now, because of this pandemic, we just go with the online thing, wonderfully created by the government, and this is a Ministry of Human Resource Development initiative. So we will see how it goes, and we will do the simulation of this experiment. All right. So is there any other picture I would like to show? Yeah, this is the grades of gravel. So we will be using a particular size, so let me say about that as we proceed. So you click the simulation link there. Of course, the aim, theory, pre-test and all you can do. All right, you can do. That's not the aim. I already explained. We want to know the crushing value of the aggregate. Theory, I briefly explained why we do that. All right, why we do that. So you want to see whether this aggregate is good enough for road construction. That's it. All right. So, sorry. So here you see the apparatus used, like a typical test, right? Like a normal test, what we see, what's the aim, what's the procedure, what are the readings we are going to take, what are the machinery we want to use, what's the equipment we want to use, those kind of things. Yeah, a person is standing there just to show you, that the size, rough size of these things, like approximate size of these things. There is a testing machine, there is a weighing machine, there's a kind of cylinder there. I will show you as the test progresses. I will show you what are these. All right. Okay. There is an arrow mark there, which will it will, you just click it. It will proceed to the next step. I think there is not an arrow mark to go back. So if we want to know the previous step and all, you have to click this pop-up procedure, so it will open up all the steps. Then you can see what is the step, one step before, two steps before, like that. So we will be calculating 3 weights: the weight of the aggregate we are using, and the weight of the remaining particles, the powder. One more will be the cylinder weight, just to we put that in a container, so we will deduct that later. All right, this is what we are going to do. So the weighing machine, they provide you nice arrow marks there. You just click there. So put the pan there, tare it so that it will become the 0. We neutralize that weight. So put the aggregate there. You can see that it's 3,500 grams. It's like 3.5 kg. 3.5 kg. So you add on this pan, so that you add the material, so that the overall weight there is 3.5 kg. This is IRC procedure. We follow this kind of standard so that it's repeatable all over our country. If I do the test here with a particular sample, the result I will get will be similar to somebody sitting in Delhi or Mumbai or Chandrasekar or anywhere. So they do the test there, and they will get similar results for the similar kind of material. Alright. So we follow the steps carefully, meticulously. We follow the IRC regulations. You don't override them. Okay, I will put 2 kg. No, 3.5 kg means 3.5 kg. Alright. So you can see there even two decimals 0.00. I'm not sure about it, whether you should be that 0.01 or something like that. But anyway, try to take one small stone there and experiment in the lab, so that you get 3.5 kg. Alright. So the next step. Yeah, now we have sieves. I will show you some sieves, why we use sieves and all. You see, IRC says you have to use a particular size for this test, which is the aggregate that is retained in 10 mm sieve. So can we pick 10 mm part, the gravel from the big chunk there, one by one, measure it 10 mm? No, it's not possible. So what we do, simple way, we sieve it. We take the sample, we sieve it, and whatever retained there, we use it for the test. So this is test preparation. This is not the test, this is the preparation for the test. After we get this material in the form IRC recommends, then we will do that test. So it's kind of the first step. It's a first step to do. All right. So what I will be doing now, you put the 10 mm there, you put the 12.5 mm there. I will show you the sieve I said, right? Yeah. These are the sieves. This is how it looks in the real world. I'm sure you might have seen this or used in soil mechanics or gradation sieve analysis and all. So this is a simpler and also standardized form. You can't use a sieve from your kitchen there. So it has to be the sieve which is prescribed by IRC. All right. So we use that. All right. Yeah. So of course the kitchen one, normally it comes in one or two specific sizes. It may fall into this category somewhere there, but on a whole, for laboratory testing, we want from bigger size to until that's very fine size there. All right. So what's happening there? You can see the procedure there on the top. You can always read it there and do it. Yeah, so they put this aggregate, the one which we measured 3.5 kg, right? So that's what we are putting here. We are using that material here for trial one. We will do 2 trials, all right? So we put there, take it. There is a mission. You see this mission. Yeah, on the right side you can see this is how the mission looks. I just wanted to show these pictures on the side so that you can have a rough idea of how it looks, all right? In practice we will see. You can actually go there and do the test, all right? So this is just a temporary measure. So we take this setup, put it there, lock it, tighten the screws there, just swoosh it on, so it will do the magic. It will shake it for 10 minutes, all right? It's an IRC standard again, 10 minutes. What will happen there? Whatever you put on the 12.5 mm sieve, some of it will go after that vibrating there. It will go to the 10 mm sieve. All right, that's what we are going to use for the test. All right, so unscrew it, remove the components, remove the setup, take out the lid. Yeah, now we have everything there. The 10 mm one, sorry, 10 mm one, we are going to use it for the study. So, okay. Yeah, let's wait. The animation takes some time, all right? So just wait there. Yeah. Now, another thing is coming, you see. They call it as mold. It's just a cylinder. In this exercise, it's just a cylinder. We are not molding anything there, all right? They use the equipment, so they call it as mold. They call it as cylinder also wherever possible, all right? So, we want to fill this cylinder in 3 layers, and we use the rod there to make as compact as possible. So that's the sample prepared. We will use that and we will take that to the crushing machine, put it there and apply the load, and then measure how much powder is formed. There is a procedure to do that. I will explain it. So to start with, the first measurement you are taking is this one, weight of the empty cylinder. So you weigh it, switch on the weighing machine, tare it, place this, and it will show some weight there, 788 or something. It showed, it disappeared now, not to worry. So aggregate used here, the retain, see which one, the retaining thing. So 10 mm sieve is the answer there, all right? So you use that. It will be a little slow, just hang on, or you can always fast forward in your video. 25 strokes you are supposed to give that. Just follow the arrow marks there, it will tell you what to do, all right? It's good, it's really good. So okay, so yeah, do the compaction. So, yeah, you have to just press it, how many times they tell you, just do it. All right, so yep. Okay, you flush it out so that there are no heaps there. Tamping is done to obtain better compaction between aggregates. There is a question there. Yes, we do the tamping, the tamping thing. So in order to make those things settle properly, all right, that's a step 5. Already we are in step 5, all right, around 12 or 11 steps there. So okay, 6th step, what we are going to do now, weight 2. This is the second measurement you are doing. The first measurement was the empty cylinder. Now with this material we are going to measure it, all right? So this W2 minus W1 will give you the aggregate weight which we are going to test. So there is a value there, and mark it down. Now the next step is to crush it. How interesting, right? So this is how we are going to pack it. There is a base plate, there is a plunger. Not to worry about all this. These are all experimental setup there to make it safe and to enable the loading process successfully done. So all these things are required. So this is the setup, this is the mission. So we put it there. You see the missions, or what's the question there? Adjust the mission to touch the cylinder and plunger in proper position. Yeah, we can always do that. You see, we just turn it so that the load cell, the loading portion will come and sit on the plunger. Alright, so we are applying 40 tons. I will just come in a second. This is how it looks, the machine. You see, mostly the difference between different loading machines is how the dials are placed, how the loading patterns are available, what kind of load, how much load we can do. So that's where it differs. Alright, so it might be very big looking like an universal testing machine, or this is a compression testing machine. So it's we use this for concrete cubes and all. Here we are going to use this for crushing the aggregate, so that's what we are going to do. You see here it says 40 tons will be applied at the rate of 4 tons per minute. Hang on guys, every minute it should add 4 tons extra weight. Machine will take care of it. So the dial will move and it will reach 40 tons. That's where you will stop. Can you imagine? Can you visualize 40 tons, 40,000 kg? Where will you get that kind of weight in that small area of the road? Because the cylinder is like 10 centimeter or 6 centimeter something like. It's a very small cylinder, right? So so in the 10 centimeter or 12 centimeter, whatever smaller area it has, it's almost like a big tire of the wheel meeting the ground surface. I would imagine like that. That's the contact area. But still, 40 tons in one wheel, where will it happen? A car can weigh from 1, 2, 3 tons like that. Maybe a truck, container truck will weigh like 20 tons, 30 tons. But that is actually transmitted to the ground from the surface through many wheels, 6, 8 wheels like that. Maybe a military tank, 30 tons, 40 tons, 70 tons. So that might transfer this kind of load, but still 40 tons for a small area is very high. Why we do that? Because we do that considering the factor of safety. We test for worst condition. Alright, that's what we do. Okay, and remember this poor thing, this aggregate can be in somewhere near the surface, or it can be well beneath the surface also. 5 feet or 6 feet below, you can see the soil is there, other materials are there. So that load will also be there to crush it gradually for a long time, not immediately. That's a different test. Okay, so having those basics in mind, we will do some fun thing here. So you just press these buttons, it looks very nice there, the dial changes, you can switch on, switch off, all those things. So what is it doing? It's crushing it. So once it crushes, which means 40 ton is applied, then we remove that. We remove the sample. So now it will not be the same thing what we put there. Some portion of it will be crushed. If the whole thing is crushed, then forget about that aggregate. So it's not useful, right? So remove the plunger and see whether, you just now the story is slightly different. Initially we used 12 something and 12.5 and 10 sieves, right? That's to prepare the sample according to IRC. Now we want to see the powder thing. Just imagine 2.36 mm, just maybe the tip of your nail, 2.36, 2 mm. So we want to sieve this sample, tested, crushed, already crushed in the machine. So when you sieve using this sieve, whatever goes through it, that's what we want to see. We don't want to see what is retained in that. Alright, we want to see what passes it. Alright, so we do that. How we do that? We put there, we drop it there, close it there. Again our famous machine comes here, lock it, screw it, switch on, let it do its job, and then we remove it. Okay. Alright, so yeah, remove it. Now there will be two pans, one 2.36 mm, the other one is the thing containing the powder. So we want to weigh that. We want to have the weight, so we tare so that we remove the weight of the pan. This thing goes there. There was some value 986 something grams. So you have all the three values. Guess what? We almost completed the experiment, because we know the weight of the cylinder, we know weight of the aggregate. With the cylinder, we deduct it, you will get the weight of the aggregate, right? Now we know the weight of the powder. You divide the powder weight by that net weight, you get a value what IRC calls aggregate crushing value. It's a percentage of the powdered form to the original form. If that is lower, very good. If that's very high, that means too much powder, too much dust, too much breaking there. That's not good. You can calculate this and enter here. That's the proper way to do it. Well, I accidentally found out that you click 3 times, it gives you the value there. Don't be lazy, just do the calculation and put it there. So this one is the trial 1. We want to make sure using couple of trials. All right, the site could have said just do it one more time and get the result, but actually they will do the entire thing again. So just patiently do it, so that it will be like learning one more time. All right, because we need to go to the last step of this simulation to ask some questions. Each layer is subjected to how many strokes? I guess it was 25 or something, right? If you make a mistake here, not to worry, just learn, do it again, and just it will say you are wrong, the answer is 25, something like that. Don't get intimidated by that. Normally we don't remember all these values, but once you have the procedure, you will do it. By practice you can remember some value. Alright, so 20, so 25. Let's wait. I will do the experiment. You can see there it will take some time. All right. Maybe in the future they will have some fast forward mechanisms. Well, in reality it will take more time than this. At least half an hour. Yeah, flush it. Cylinder is filled with aggregates in how many layers? I think 3 layers. Yeah. It's not a big knowledge kind of thing. It's a procedural thing. This meticulous in-depth procedure will make sure that repetition of results possible. The more things you specify like this will ensure that you will do the things correctly, will follow the procedure correctly, so that we can compare the results. There is some use for that. So we are repeating the exercise, guys. So just take the weight here again, put it there, and put the plunger. Go to the next step, put this in weight. I'll show you a picture for some change. You see this professor, this gentleman from one of the IITs, in a video I saw this, he's placing that sample there for the test. So those videos are available, plenty of videos like this available online, whether from India or from overseas. You can always check it out if you are interested in that. Okay, load applied to plunger at a uniform rate of 4 tons per minute. Uniform rate of 4 tons per minute. Alright, so 40 tons, right? So that's what we applied here. So let us do the dial has done its job. So we will remove it. Yeah, just hang on for a second. So remove the sample there. This is trial 2. Identify the apparatus placed on the mold, actually placed on the cylinder here. So which is the plunger one. Alright, so that's the connecting part between the load and the sample. So procedure we follow. Alright, so remove it, take the weight, put it in 2.36, put the material there, cover the lid, do it as a fun, so tighten it up and screw that, let it do its work. So now the powder will filter through the seal and reach the pan. We want to take the weight of it. So you know what, this is how it will look. You see, professor is showing there that the last one, the bottom one, right? This is how it will look. This is the crushed powder. Can you imagine that machine, how powerful it is? 40 tons you apply on small stones, you get powder there. Alright, so just imagine. Of course, if this happens in the field, you will have bumpy road. Alright, so many other issues in the road also, not only the potholes, but we will have a lot of problems when your main base layer, sub base or subgrade, wherever you use this gravel, if it is spoiled by crushing, then we have a problem there. Alright, so that's why we want to make sure that whether before using the aggregate, whether it's suitable or not. Well, so you enter the second row. Now you have an average. Alright, so you have an average there. Since aggregate crushing value above 35, where is above 35? Yeah, average value is 37.975. I don't think you need 3 digits, but if IRC says use 3 decimals, use it. Alright, so 35%. This aggregate would normally regarded as weak aggregate. So if it is maybe 5%, 6%, maybe it's good. But if it reaches 35, 45 means almost, if it's 50, half of it is crushed. Alright, half of it is crushed. So that's not good, right? So that's the thing. So guys, good news, we completed that test. This is the screen. You will take a screenshot or a photograph, picture in your mobile and convert it to a PDF file, submit it as an assignment in Teams. So I will open a folder there under assignments, crushing value or lab test. I will name like lab test 1 aggregate crushing value. So everybody should do this, do the procedures for learning, do that, and the final snapshot should be this one. Put it there as an assignment there. Alright, so we will repeat this for every test. We will do this for every test. You follow the procedure, learn it, follow it, take the snapshot, put it there, then we will consider that you have done the experiment in online mode. Practical mode, after university reopens, we will see about that. Alright, so that is the thing. Now you might think, why 35 is weak, higher the value, weaker. Can we have some more values there if you want? I think the values are there in theory link. Let us see, just a quick look on that and we will conclude. Oh yeah, here it is, aggregate limit. So it says 50. So if it is more than 50, you can't use it for soiling. If it is more than 40, you can't use it for waterborne macadam roads. So if you want a bituminous macadam road, bitumen plus gravel plus chips and all, so the limit is 40. So they even allow up to 40% can be crushed. But of course, we will see like 7, 10%, 20%. Less than 10% may be miracle. It's like a pakka stone, it can't even crush. Alright, so this is the basic idea. Alright, rigid pavements, they are using 45, 30. See, they expect very high strength there, very high rigidity there for dense mixed carpet and all. The IS code followed is mentioned there. Alright guys, any other picture? Yeah, this is how we test aggregate for its crushing value. Alright, then we find whether it's suitable and we use it. Thanks for listening to this presentation. I think it will be useful for you guys. Do the test, submit the assignment. Alright, thank you. See you in the class.